Today's lesson is called Linear and Nonlinear Functions. So for the opening exercise, I'd like you to look at the following chart. It says the following chart contains both linear and nonlinear functions in X. So they've been grouped already, but there's no headings on these groups. So what I would like you to think about on your own is which group do you think are the linear functions? Which group do you think are the nonlinear functions? And then explain how you know. So at this time, I'd want you to pause the video, answer that question, and then you can come back to the video to resume. Okay, now that you've had a chance to take a look at the opening exercise, there's probably a lot of different answers that many of you put for which group you think is which and why. So what I'd like to do is go over the big idea with you, and then we'll revisit the charts. So, in equation form, a linear function has variables whose exponents are 1. It can be written in the form y equals mx plus b. On the contrary, a nonlinear function has variables whose exponents are not 1. So we don't have to say what they are. We don't have to say it's a 2, it's a 7. It's better to stick to linear has exponents of 1, nonlinear exponents that are not 1. That means it cannot be written in the form y equals mx plus b. So let's go take a look at the chart and see what we notice up there. If you figured it out, group 1 are all of my linear functions. If we take a look at the chart, if I don't see a number on a variable, that means it really has an exponent of 1. We know that from when we learned our exponent rules earlier in the year. So if I go through and mark these equations, all of my variables have exponents that are 1s. So that's how I know they are linear. If I look at group 2, I see here I have an exponent that's a variable. In the second one, I see that there's a variable, but it's actually under a square root. So that makes it different. In the next one, I see an exponent that's not a 1. And in the last one, even though there's a 1 on this x, there's an exponent here that's not a 1. So these are my nonlinear functions. So it's okay whichever way you answered the which one do you think, because this is not something you know about. We were asking you to look at some categories and see what your thoughts were before learning more information. So now we know that if you're linear, the variables have an exponent of 1, and nonlinear, the exponents are not 1. If it's linear, you should be able to write it in the form y equals mx plus b. If it's not linear or not exponents of 1, then you cannot write an equation in y equals mx plus b form. So looking at the nonlinear side, there were a couple special cases that we talked about. And I want to pay attention to those in our next statement. Your variable cannot be the exponent. It cannot be under a what we call radical, which we talked about during the real number system. So things like square root, cube root, or in the denominator. So again, if any of those things happen, that means you have a nonlinear function. And again, if I go back up and look at the chart, y equals 4 to the x, there's the variable. Y equals the square root of negative 4x plus 5, there's the square root. Okay, and in the last one, x was in the denominator. So we're going to talk more about that with our examples, why that turns into an issue. So let's look at some examples together. Number 1 says, is y equals 3x to the 5th plus 4 a linear or nonlinear function in x? Why or why not? So we want to take a look at the exponents. Either I have exponents of 1 and it's linear, or I do not have exponents of 1 and it's nonlinear. So when I look at this, I see this right here that is not a 1. So that tells me that this is nonlinear. And there are a couple different ways I can describe this. The first way I could say is because the exponent, and I'm going to look and see which variable it is. It's x, so the exponent on x is not a 1. So notice, I didn't write that it was a 5. Sometimes it's obvious to tell, but sometimes it's not, and we may make a mistake. So we want to stick to it either is a 1 or it's not a 1. So we'll say it is not a 1. Or your other option would be that it is not in y equals mx plus b form. So we know a linear equation, a linear function, should be having a slope and having a y-intercept. So this equation's not in that form. Number 2, is y equals 1 over x a linear or nonlinear function in x, y, or y not? So if we go back to the big ideas and we actually look at this last starred point, remember, it's nonlinear if the variable is the exponent, or if anything's under the radical, or if the variable's in the denominator. So technically, this fits the denominator case, right? It's in the bottom. I know it's nonlinear. But when it comes to the explanation, let's really understand why this is happening. I'm going to come over here on the side and write 1 over x. If I don't see an exponent on the variable, I know it's a 1. So at first glance, you're like, oh yeah, it looks like there's a 1 exponent. But we have to think back to what that really means. Thinking exponent rules, anytime I flip a fraction, it makes the exponent the opposite of what it was. So that means that 1 over x to the first really came from x over 1 and changing the exponent to the opposite, which means this originally came from x to the negative first. So that's why anytime you see a variable in the denominator, it's nonlinear. That means it originated from a negative exponent. The exponent rule was used on it, and that's what changed it into the positive on the bottom. So we have to be really careful here that we don't think the exponent on this x is a 1. It is not a 1. So I'm going to say because the exponent on x is not 1. We can say that up here too. Now I'll put a little star so that you remember it relates to the star up above. This would be that example where it's in the denominator. So if we move on to the next example, example 3, which equation does not represent a linear function? So now we've got some choices. So let's take a look at our options and do a little simplifying if we need to figure this out. So in choice A, I do see distributive property. So I'm going to simplify this. And it becomes y equals 2 times x is 2x, 2 times negative 3 is negative 6. So looking at that, I see that it's y equals 2x minus 6. I see exponents of only 1. Or I can say, all right, it's in the form y equals mx plus b. So I know it's not that one. When I look at b, I see an exponent that's not a 1. But if I look at closer inspection, that exponent is on a number. So I can actually simplify this to y equals 2 to the second power, or 2 squared, means 2 times 2, which is 4. So this turns into 4 minus 3x, or y equals negative 3x plus 4. So now I can see once again the exponents are 1s, or it's in the form y equals mx plus b. When I look at choice C, there's nothing to simplify. If I go in and inspect, I don't see exponents on y or x, which means there's actually 1s there. And when I look at option D, I see an exponent that is not a 1. So that means if I'm looking for which equation does not represent a linear function, I'm looking for the nonlinear one, which means choice D is my answer. And that's because the exponent on x is not 1. So our last example is example 4. The two equations shown below represent different functions. So function A, we have v equals 1/3 pi r squared. And function B, we have P equals 2L plus 2W. So these are actually two formulas. Function A is the formula V equals 1/3 pi r squared that we learned during the volume unit. And function B for perimeter is actually a rectangle particularly. So they want us to identify each function as linear or nonlinear, state a reason why each function is linear or nonlinear. So let's look at function A first. If I look through, I see the v exponent of 1 because I don't see anything. And as I continue to look, I run into not a 1 on our variable r. So that means function A is nonlinear. And my reason is because the exponent on r this time, because that's the variable affected, is not 1. Looking to function B, if I go through and inspect, nothing to simplify. I don't see an exponent on P, so that means it's really a 1. I don't see one on L or W, so that means they're all 1s. So that means function B is linear. And my reason would be that all variables have an exponent of 1. So now that we've discussed the definitions and gone through several different examples, I'd like you to move on and do the closure question. I'd like you to try to write an equation of a function that is not linear, and I'd like you to use your equation to explain why your function is not linear. So at this point, please pause the video and try those two questions, and then resume the video to discuss. So now that you've tried the closure question, write an equation of a function that is not linear. So remember, if it's nonlinear, that means exponent is not 1. So there's lots of different things you could have chosen, and I'm guessing I probably won't write the same thing as you did, but if you're unsure of yours, let me give you an example of what I might have written. I wrote y equals 2x squared. So if I had to use my equation to explain why my function was not linear, I have a couple of choices. I could have said the exponent on x is not 1. Or I could have said it's not in y equals mx plus b form. And either of those would have been a good explanation as to why it is nonlinear. And that concludes your lesson on linear and nonlinear functions.